Yo, what's up everyone? Welcome back. Patrick here, moving on to the next example. So we're given this function here, 2e to the power x plus 3 times e to the power negative x all over 2. And we got to find the inverse of that there. Now this was sent to me by a student recently, decided to make a video of it because it's a pretty intense question. There's going to be a lot of steps. I'm going to do my best to explain it. But this is pretty much as tough of an inverse question that you can get. But I'm going to try to simplify the steps as much as I can for you. So first thing I'm going to do, I rewrote the function. Instead of putting f of x, I put a y here. And what's the first step in finding an expression for the inverse? We got to interchange the x and y values. So instead of this y, I'm going to put an x here. And then for these x's, I'm going to put a y. And so now what we got to do is we got to find a way to isolate for that y. And then if we can isolate for that y, that remaining expression is going to be the inverse. The question is, how do we do that here? Notice that it's going to be kind of tough because the y, not only is it in an exponent, in two exponents, but the exponents are different. This is positive y, this is negative y. So what can we do? So first thing I'm going to do is I'm going to put this x over 1. I'm actually going to cross multiply here. So we got 2 times x. So we would have 2x here. And then this here is going to be 2e to the y. 1 times this numerator is just this numerator left as is. Plus 3e to the negative y. And actually, instead of writing e to the negative y, I'm going to write it as 3 over e to the y. And the reason why is because now we got two expressions that are the same thing. We got e to the y here, we got e to the y here. Even though it's in a denominator, it's still the same. And so what I'm going to do for now is I'm actually going to make a substitution. I'm going to bring in a new variable m, and I'm going to sub it in for this e to the y, just to make the algebra a little bit more simple. And then I'm going to try to isolate for this m here, and then at the end I'll bring back this e to the y and sub it in for the m. So I'm going to rewrite this up here. Actually, you know what? I'm going to rewrite it here just because I feel like I'm going to need a lot of room. So I'm going to rewrite this as 2x equals 2m plus 3 over m, like that. And I'm going to just make a note over here that I let this m equal e to the y, like that. Right, so now it looks a little bit better, right? There's no exponents to deal with. We just got to isolate for this m. The question is, how do we do that? Well, what I'm going to do is I'm actually going to get rid of this m in this denominator. And the way we can do that is we can multiply everything by the lowest common denominator. So notice this 2m is over 1, this 2x is over 1. So we can multiply everything by m. That's the lowest common denominator between m1 and 1. So what we would end up with is 2xm equals 2m squared plus, and then notice these m's cancel out, and we end up with just a 3 there. Right, so that's how we got rid of that denominator, just multiplied both sides by m, kept both sides the same by multiplying it by the same expression, and it's just now notice that there's no fractions here to work with. So 2xm equals 2m squared plus 3 is the exact same as 2x equals 2m plus 3 over m. And then from here, what we can do, remember what we're trying to do is we're trying to isolate for this m here. So what we can do is we could bring this over. So we'd have 2m squared. I'm going to write this 2xm here. And then we got this plus 3. And so remember, we're trying to isolate for this m here. And notice that this here, it's a quadratic equation, right? Ax squared plus bx plus c equals 0. This is in that format. It's just in this case, the a value is 2. The variable that we're dealing with is m. What's the b value in this case? The b value in this case is negative 2x. Okay, this x and this x are not the same thing. You know what? Let's maybe actually just, instead of putting an x here, just so you don't get confused, I'm going to put an m. Okay, because that's the variable we're dealing with in this case. And then the b value is this entire expression, negative 2x, and then the c value is 3. Okay, so this here is just a quadratic equation in that format. So from here, the a value is 2, the b value is negative 2x, and then the c value is 3. Now, when we have a quadratic equation, okay, if we have am squared plus bm plus c, what's the m equal to? Well, it's equal to negative b plus or minus b squared minus 4ac all over 2a. Okay, just the quadratic formula. And so that's how we can get an expression for m. That's how we can isolate for the m in this case. And so what we can do is, using this quadratic formula, we can now plug in these expressions for the a, b, and c, respectively. So we would end up having, I'll start writing it up here. We would end up having negative b, so negative 2x is just positive 2x, plus or minus negative, or b squared, which would be negative 2x squared, that's got to be in brackets, minus 4 times the a value, which is 2, times the c value, which is 3, and that's going to be all over 2 times the a value of 2. Like that. Right? So just took this a, this b, and then this c, and put it into the quadratic formula. And so now we can get an expression for this m. That's what we're solving for in this quadratic equation here. Okay, and so now what we got to do is we got to simplify this here. So what would happen is, inside the square root, negative 2x squared, the negative 2 has to get squared, which would give us 4. The x has to get squared, which would give us x squared. And then this would be 24. Right? Minus 4 times 2 times 3 gives us minus 24. And then this here is all over 4. Now this here we can actually further simplify. So what we can do here is we can factor a 4 under the square root. So we'd end up with x squared minus 6. This is still all over 4. And notice that we got two expressions that are multiplying under the square root. And whenever you got two expressions that are multiplying under a square root, basically you can multiply both of those expressions separately. Both of those expressions have to be under the square root still. So we can rewrite this here as m equals 2x plus or minus the square root of 4, the square root of x squared minus 6, all over 4, like that. Okay, and now continuing this up here, we got m equals 2x plus or minus, now the square root of 4, that is 2. And then we got the square root of x squared minus 6. Can't really do anything with that. And then we got this 4. Right? So took that original expression that we had, and we're simplifying it to this. Right? So now what we can do is we can actually factor out a 2 from both of these expressions. Okay, took out a 2, took out a 2. This is all over 4. And now notice this 2 goes into this 4 twice. And so what we would end up with is m equals x plus or minus the square root of x squared minus 6. And that's going to be all over 2. So notice that we achieved our goal in terms of isolating for that m, right? We isolated for the m and notice that it's all in terms of x. Now, the thing is we're not isolating for the m. That was just within the process. We got to isolate for the y. So now at this point, what we do is we bring back that e to the y. E to the y equals this entire expression but now we got to isolate for this y. How do we do that? Well, if you remember your exponent rules and log rules, if I got e to the power of some kind of expression and equals another expression, and I want to isolate for this a here, what I can do is I could ln both sides, bring the a down. Ln of e is just 1. And so basically, if I got this and I want to isolate for a, it's just equal to ln of b. Like that. Right? So to go from this down to here, it's just this rule here. A is just going to equal ln of b, and we can go the opposite way. We're not doing so in this question, but if you're in this format and you want to isolate for that b, you can put it into that format. And if you want to show your work for that, basically you ln both sides. The y can come down, and then ln of e, you would end up with ln of e here. Ln of e is just 1, right? So you would end up getting that y by itself, and you'd end up with ln of x plus or minus the square root of x squared minus 6 all over 2. And so that there ends up being the final expression for the inverse of this function. All right, so fairly complex, lots going on there to isolate for that y, but nevertheless, that is the process you go through for a function like this in order to get the inverse.